Thanks for coming, everybody. Rob's giving a talk on stood execution in the big room. If I wasn't here, that's where I would be. So I disagree with your choices, but I appreciate the support. My name's Vito Gamberini. I'm one of the lesser known speakers here. I wouldn't know about me. So the very, very quick introduction is I used to do stuff on submarines. There's me doing stuff on submarines. I was into submarine propulsion, reactor INC control. This is a Westinghouse 5th generation submarine control panel. Coincidence circuitry, pneumatics, hydraulics, all that good stuff. Neutron detectors. As I wound down my career in the Navy, I was looking for something that would have sort of the same level of system integration problems, same level of complexity, same level of something went wrong over here on the other side of the universe and it shows up on the, the right side. And that's how I got involved with C++ build systems. So the standard cop-outs so that you can't hold me responsible for anything I say here. I work for Kitware, but I don't speak for Kitware in a big official capacity. For that you need Bill over there. I work for the CMake team, but you get the idea. Brad King still overrules me on everything. No promises, no commitments, and I reserve the right to be completely wrong on anything I say in this talk, but I will do my best not to. So I had an agenda when I first proposed this talk months ago. I was going to talk about some pragmatic CMake stuff. That would be 45 minutes of the talk. Then I would transition to the new stuff we put in, C++ 20 modules. And I figure I would finish it off by talking about the cutting edge common package specification that we were putting in. And so I've had to make some adjustments. This talk has been written basically over the last 16 hours. I haven't practiced it. I don't know how long it's going to go. We might be done in 20 minutes. We might end halfway through. So let's get started. We called this talk from 3.0 to 4.0. I've decided to expand that scope just a little bit. I want to talk about the CMake eras all the way going back to CMake 1, because I think it tells an interesting story. As I'm sure many people in here know already, CMake major versions are not feature versions exactly. Usually it's because we're taking things away from CMake. It's when we remove features. That said, they're spaced far enough apart that they are useful as a mechanism to sort of talk about generations of CMake. So CMake 1.0, 2000, the original Bill Hoffman release, was a very different language. It's sort of like someone speaking with a heavy Dutch accent. You can recognize all the consonants, but the words don't make sense. It was also released during acute shortage of lowercase letters, so it is all screaming at you. There's some interesting things in here. The italics are because my editor was desperately trying to tell me that I'm using a CMake command that was removed in the last Bush administration. There's something interesting that I thought was neat about this is that you still see, and there were reasons for this, but you still see this style of sources at the top, then a list of files, and sometime later you call add executable and you pass that list to it. This hasn't been relevant in CMake since 3.0. It's not a useful way to do things. So when you see this, you can tell people they're writing code from 2000. This is not a useful mechanism, but it starts here, right? So we still see this idea, but there's not a lot of lessons to take out of CMake 1.0. We'll move, forgot. One thing, CMake 1.0 landed all of the big find commands, including find package. This answers a classic question for CMake that you will see come up over and over again if you argue about it on Reddit like I do, which is, why did CMake not just use package config? The answer is package config got posted to the no mailing list in June of 2000. CMake got posted to the ITK mailing list in August of 2000. And by January 2001, CMake had already sort of expanded beyond the capabilities of what package config could do for discovery. Package config can't describe an executable or a code generator or anything like that. So the answer is, they grew up together. They were in their own insular communities. Package config doesn't predate CMake. They went to high school together. So CMake 2 is world domination time. CMake 2 doesn't have a theme to it. We have all sorts of random commands that start to get in here. Add subdirectory, replace the weird subdirs. We got the policy system in CMake for maintaining backwards compatibility. We got the ability to enable a much wider variety of languages. We finally got function. It was only macro before that. Install, general purpose install came into the fold in CMake 2. Before that, it was all very specific. You install targets, install file. General purpose install comes in CMake 2. As sort of the philosophy of always say yes, right? A customer has an issue. We're going to solve that issue for them. CMake gained the ability to do math in CMake 2. Should your build system be, does your build system need floating point multiplication? Someone needed it. And if you want to beat Make, right? If you want to beat Make in Visual Studio, if you want to gain those network effects, you need that guy to use your build system. You have to, at the bottom, you have to say yes to everyone. Then you can improve. CMake 2 said yes to everyone. My favorite example of this is, does anyone know, I'll take just shouts from the audience, how many variables does the project command set up? Directly, not like as a third-party consequence, in the command.
It depends. 5?
It does depend. 5 is a good answer.
At least 5.
I'll take a minimum or a maximum, anything in the range.
I think 7.
Okay, so project name is good, right? That's a good one to set. Project version, that's pretty good, right? These get set regardless of whether you pass keywords to them because they get set to empty string.
Is that all in CMake version 2 already?
Almost all of it lands in CMake version 2. I exceeded a little bit with some experimental features, but almost all of it lands in CMake 2. Binary dir, source dir, that's 4.
But should it show also version major and minor?
So you're spotting some other ones? It's 30. There's 30 variables set by the project command. Yeah, so I went through about 15 of these, searching them on GitHub to see if there's any usage, and there is. Each of these is subtly different than the others. Someone needed it. We added it. We maintain it. This is how you maintain world domination. You say yes to everyone. CMake 3. Everyone knows this one. I hope you like target commands. We invented the target model, we made the world a better place, and we solved all C++ build problems. Most of these are actually from CMake 2.8-ish, but it's really the 3.0 era that this came into vogue. Target link libraries is actually way older than all of this, so it doesn't get included in this command. But target link libraries got the facelift that all the other target commands got, which is the private interface public phenomenon, concept, idea applied to it in CMake 3. I want to spend just a little bit of time on this. I'm sure the room knows it very well, but I find these scope keywords are not as well understood by people who aren't kind of immersed in the CMake property system and its nuances. So let's say we have target link libraries. I have a target named VitoLib. Who cares where it came from? It's a target name. VitoLib is going to have 2 properties associated with it: link libraries and interface link libraries. Now, target link libraries takes as an optional private interface or public. If you don't specify, it is public. So, but it's always going to be associated with one of these, private interface or public. If I pass some name, a library name, whether that be a target or just some raw thing I want to pass to the linker, it's going to get associated, that name is going to get associated with one of these 2 properties that are attached to my target. If I say private, it's going to get attached to the link libraries. If I say interface, it'll get attached to the interface link libraries. And if I say public, it gets attached to both. So there is no such thing, and this is a useful point. There's no such thing as a public property. Public is the union of the non-interface and the interface property. So why do we have interface and non-interface properties? Let's say I have VitoLib and I want to build it. VitoLib has some dependencies that I've expressed via target link library. What I'm going to look at to figure out the dependencies I need for build is the non-interface link libraries. There I will find curly, another target. But I'm now trying to use curly. Presumably curly's already been built, and it might have some other dependencies associated for its users. To find those use dependencies, I will look at interface link libraries. So, link libraries for VitoLib for the thing I'm trying to build, interface link libraries for everything I'm trying to use. And then I will find some transitive dependencies and so on and so forth until I exhaust this transitive closure of interface links. When CMake developers use the very colloquial terms build requirements and especially usage requirements, this is what we're talking about. things associated with either non-interface or interface properties that express some requirement for producing a target. So the question becomes now, what is CMake-4 era going to be about? We just shipped CMake-4, so it's very young. We don't know exactly what this is going to become. To be clear, the CMake-4 release, all we did was remove things for the most part. We got rid of a whole bunch of 2.6 and older code, well, 3.5 and older code.
Can I just add that you removed the stuff and broke a lot of things on GitHub on Actions because GitHub runners use Ubuntu and Ubuntu installs CMake-4 by default. And then since you dropped the minimal support version, right, it was a lot of things broken.
Yeah, every time someone tries to use an old CMake 3.5 or older policy, I have it on good authority that Brad King has like a warm feeling in his heart. So what is CMake 4.0 going to be about? I think if I was going to title this movie, it would be The Packaging. CMake 4, The Packaging.
What kind of movie is that?
We're going to really improve the way install and find package work. This can mean integrating with standard packaging, integrating with what we're starting to call like provisioners, things that set up build environments. And it could also be moonshots. CMake 3 had some moonshots in it that aren't related to anything else we talked about. CMake 3 gained a debugger, right? That speaks the debug adapter protocol. It can work with any development environment. So there are moonshots things that we can have room for in CMake 4 as well. To talk about CMake, we need to establish some sort of base level of knowledge. So we're going to talk about the tale of three trees. This is not a CMake concept. This is a building software concept. Everyone should be generally familiar with what a source tree is. I am going to define a source tree as whatever you have is in version control. Whatever you pull down in Git, that's a source tree. And that's a good enough definition for our purposes. I'm going to stop just long enough to say some things I really want you to keep out of your source tree. I really want you to keep other people's source tree out of your source tree. Do not get your chocolate in my peanut butter. They're meant like, don't mix the peas and mashed potatoes. Don't put gtest inside of your HTML parser. That includes Git submodules. Vito's first rule, Vito's law, put it on Wikipedia. You have a problem space. The answer is not Git submodules. I've softened on vendoring. Vendoring as a way of last resort for users who are not going to provision the build themselves can sometimes be okay, but the only project I've ever seen that does it in a way I like is CMake itself. If you want to talk about how they do that, find me after. It's involved. But by default, you should not be using vendored sources. The second tree is the build tree. The build tree is populated by artifacts. We do this in programming sometimes where we create terms for things that are very silly and simple. So dependency injection is just a name for passing parameters, right? Artifacts just means stuff, right? Is it good stuff? Is it bad stuff? Depends on who you ask. But there's just a lot of stuff in here. It's not useful in this form. We need to pull the good stuff out and organize it in a way that we can make use of it in dependence and further deployments. That is the job of the install tree. When we pull the artifacts that we care about out of the build tree and organize them in a way that is useful for further consumers. This is the three trees model. CMake is primarily concerned with describing the movement of artifacts and sources through the three trees. That's the job of CMake. So, how do we describe a source tree in our postmodern world of CMake? I posit to you that almost everything you do can be described as a file set. Okay? Target sources file set is how we describe the availability of objects in the source tree. So on the left, I have the documentation version, and on the right, I have a filled out example of it. So I have some target. It has some scope keyword that just controls whether we're setting interface or non-interface properties. File sets have names. So in this case, I've named it private headers. They have types. So things like headers and modules, right? That describes their usage. There's lots of reasons you want to do this, right? Modules and headers get installed to different places. Source files and code gen things are different kinds that have different behaviors. Basters for things like include and embed, that's going to be a path. So your -i flag to your compiler that says, where does this thing live? And then when I install it, what part of that path gets relocated? Basters is our include, and then we have some file list. Now, I'm going to expand this just a little bit because I think people get confused about this basters idea a lot. And I think if you expand, it becomes more obvious. Files, let me rephrase this. Base directories are almost absolutely, all paths in CMake, in the general sense, are either relative to the current source directory or absolute. And those are your two options. So if you give a relative path, assume relative to the current source directory, otherwise absolute. Here I have two absolute base directories, and then I have a list of files. So Vito.hpp is not going to be relative to either of my base directories. It is relative to the current source directory. Now, I happen to have a path current source directory as one of my basters, but that's not a given. And then I have a separate set of files and headers, one given as absolute and one given as into a different base directory. What happens for header files in particular is all of these base directories are going to get coalesced into a single directory on install. But that doesn't matter.
But it's private.
And it's private. Okay, so we'll come back to that. If this were something that was going to get installed, they would get coalesced. Thank you. If this doesn't make sense, don't worry about it. We can talk about it some other time. Base directories and file sets are a little bit complicated and hard to do on slideware. But this is the basic idea. Now, we can start cutting away from this. So, two identicals. I don't like the way file sets are taught because they are taught with sort of all the fixings on them. But this is not necessarily how I use file sets. It's overwhelming for contributors when they see this, and the extraneous information that gets put into them doesn't help you understand what they're trying to do. So I'm gonna start pulling stuff away from this. First things, we have this sort of name and type. But file sets have a neat trick, which is that if you use the name of one of the reserved names, so like a type, this is kind of like a special name. So this is still a name, the name is still headers, but for the file set that is named headers, CMake automatically understands that its type is also headers. So that's a shortcut, right? So most headers, so if you have one group of headers that you're using that you want to describe, and sort of like your default group, usually like your public headers. Shortcut. Base directories, CMake current source dir, that's the default. Get rid of it. And now your files, just relative to your source directory. But as has been pointed out, this is private. I don't need to enumerate my private headers. They're going to get caught by dependency scanning. Now, if you want to do it for cleanliness reasons, be my guest. But we're going to ask the compiler what your private header dependencies are no matter what. Yeah.
Well, I was going to say, is that like just as part of like the dependency calculations for incremental builds? Like you
exactly.
Just use that as well?
Yeah, so we're gonna Brett?
And your favorite IDE might appreciate the extra metadata.
Yes. So it depends, right? But we're gonna -m no matter what, or minus include headers for, I forget what the MSVC's flag is, but we're gonna do that no matter what. So
right. It'll build, but it won't show up in the IDE.
It won't necessarily, yeah.
And the extra verification feature, I don't know if you're gonna get to that or not.
Oh, not for private. That only runs on public.
It doesn't do verifying the private?
Only does it on interface. Yep.
So does that mean that like, yeah, if you don't say anything, just automatically, and is that only headers that are like under CMake projector, or because like you might be bound including things that come from the system or something like that as well.
Unless you tell GCC to exclude system headers, it's going to include everything it can find when it pops out that make file. That
right, but so what I mean is that for the purposes of the file set here, if you didn't list the files, like system headers and stuff would get included as part of the file set.
Oh yeah.
For the incremental build, yeah.
Okay.
If you wanted to model that explicitly, you should really do an import and target, which Vito's probably not going to cover this.
Not in this part.
Right.
So
yeah, I know it needs that for dependency calculations, but I was just wondering for the file set.
No, unless your IDE needs it, I don't typically list these files,
So,
these
right,
privates.
so to be clear, the file set is for files that are part of your library. So you would not list anything under, say, user.
Yeah.
Yes.
Because that's not part of
Oh,
your
yes, absolutely. If it doesn't belong to you, don't ever put it in a CML.
If you vendored in some dependency, despite Vito's recommendations against it, also do not put that on a file set for your own code.
Yes. So, these are private. You can remove them if you don't want specific IDE features that rely on them. I never list them. And now we have this. So this is like a postmodern way of saying something that we already had in CMake 3. This is target include directories. Just how you spell it in the new postmodern target sources world. So we have target sources, file set headers. We have a bunch of other target sources. We might want target sources for embed, right? This is basically just headers, but it's a different kind of headers. Or for C++ modules, or for sources. All kinds of projects, and we're not limited to this. We can continue to add more. But for C++, this is like a good starting point, right?
To be clear, which of these are supported?
So the truth is, of course, that these don't exist. We have a stale patch set for sources. It got hung up on some edge cases. I want to revive it very soon. And we have an open issue. We know how to do embed correctly. We just haven't had the manpower and the time to do it correctly. Yes.
How would sources work? Because my thought with headers is that basically you're discovering the headers from the enumerated header, like the information the compiler gives you back, given that you know your sources.
Sure.
Is this just like globbing for files?
So this is what we actually have today, right? We don't, embed just doesn't exist.
Yeah.
And we do obviously have a way to describe sources. We just don't call it file set. We just leave the file set out of there. The advantage of being able to describe sources inside of a file set is right now using the standard CMake nomenclature for a list of sources associated with the target. What CMake needs to do is, let's say part of that list of sources is generated code. Okay? CMake doesn't know that. CMake has to wait for all of the sources to become available, and then it can go embarrassingly parallel. If we had file sets, we could describe, hey, this file set doesn't have any generated sources in it. You're ready to go from day one while the generator is running in parallel. And once the generator is done, then it can go to its own file set and we can compile that in parallel. This idea of splitting this up has edge cases to it that are difficult. So that you can go pull down the slides afterwards, go read why the patch got closed, but it has known issues. So this is how we spell everything today. Embed isn't here yet. This is how you spell target sources. But there's one more thing I want to talk about with target sources because I see it used excessively. And what I mean by that is in any given CMake list, CML, in any given CML, for one target, you only need to call target sources once. This is a style issue. But you can just chain target sources. Every single scope keyword is its own subset of sources. So you can say, these are my sources at the top, and then you can transition to your private header set and then your public header set. And all just works. Note here, I can't have my private header set and my public header set have the same name. So I had to give private headers its own name and then enumerate the type, yada, yada.
Is the header file set, is that exposed through the CMake file API?
Yes, but not well.
Okay.
The other caveat is the overlapping base directories.
Yes, so if you have a given file set with a given name, your base directories have to be non-overlapping. You can't have nested base directories. If you want that, just give them different names, make them different file sets. So that's the source tree. How to describe the build tree in CMake. So we had our three trees, right? We had source tree, build tree, install tree. So to describe the source tree in CMake, just don't talk about the build tree. Leave it alone. Its layout is effectively random for your point of view, for most source books. Now, there's a bunch of advanced people in this room that are like, my tests require this. The documentation is there for you. You typically run tests out of the build tree. You don't need to install it first. If your tests have assumptions about some file layouts that can't be just described kind of in CMake pseudo target language, then yes, go read that documentation, figure out how to get your build tree laid out in a way that will make your test pass or that is necessary for them to run. If that isn't a problem for you, don't touch it. You don't need to coalesce all your binaries into build bin. doesn't matter because you shouldn't be consuming anything out of that except for testing in the first place. If you're LLVM and you do regularly consume things out of the build tree, I don't know, find me in the parking lot later. We'll hash it out. So, how to describe the install tree. I've reworked this talk to use Beam and exemplar examples. I like Beeman a lot for this for a couple reasons. One, because it's correct. Nothing Beeman does is wrong. And yet, I can still find issues and make fun of Brett. So,
Good job.
we're going to talk about it. So, at the top, the target names. Targets is fine, right? This is an enumerated list of targets that you want to talk about moving into the install tree. So, they're associated binaries, they're associated archives, they're associated share objects, what have you. Component name. I want to make it very clear because component is overloaded in CMake land, that the component name here is talking very specifically about a single flag in the CMake install sub command, which is that if you divide your package into components and you only want to install some of them, you can tell CMake install only install this component name with this name that's been given here. That's the only use for this field. If you only have one component, I don't list it. It has file API effects. There's reasons you would do it. I don't think Brett's wrong here, but I don't do it. Export, Beam and exemplar. What this is discussing, and so this is one of the issues that I kind of have with this, which is that we have Beam and exemplar 3 times in a row and no real distinction between what the name is. What the export group is a name to describe the collection of packages. So what we typically name these is targets, and the reason for that is it's going to become very clear in a few slides. But it becomes more obvious if we had more targets, right? If we had some collection of targets, and we wanted to give that collection of targets a name, we would give it a name like package targets. And so this is sort of the more typical conventional way. But there's nothing wrong with it. There's nothing wrong with how the command is structured. Just some of the naming conventions are a little bit wacky. Okay, so back to what Beam and exemplar has. We have all of these destination commands. These are describing where in the install tree, because remember, we're describing movements of components. At this point, we have built everything. The build tree is populated, and we want to describe how we're moving artifacts out of that build tree into the install tree. Install gives us the capacity to describe where artifacts are going to land. Destination gives us a default. I haven't described where this is going to go. Use the destination. Install supports this list of what it calls artifact kinds, which is about as like computer science-y a name as you get, which say, for certain categories of stuff, I want you to put it somewhere else. So here we have runtime, which is binaries that we want to get into CMake install binder, and file set headers, which is what we were talking about before. When we're describing file sets of headers, I want them to end up in CMake install includer. So, yeah.
So, okay, so yeah, I was originally wondering, is destination, like, if you don't specify, is it that it applies to libraries? But no, it sounds like that applies to everything that is not a binary.
That's not, that we haven't specified an archive kind sub thing for.
So why would you want to like put, like just your binary targets, library targets in a debug there when your debug configuration, but you don't care about that for...
I'll come back around to that.
Oh, yeah.
We'll have that out.
Okay.
I'm probably agree with you.
So, here's my issue with this right now. These variables work like this. These are our archive kinds, more or less. They get their default names from a misunderstood macro called GNU installers, which I'm not going to talk about unless I have too much time at the end. And they have a set of built-in defaults if those. So the way these work is you have some runtime artifact, right? If CMake install binder is available, if it's been defined, that's the path that we'll use by default. If you haven't given it a different path. And if CMake install binder is not defined, the command just falls back to bin. Okay, it's pretty straightforward. Note, file set headers goes to CMake install includer, and its default is include, which is a reasonable default. File set headers destination CMake installer. Get rid of it. It doesn't. It's overloaded. We don't need to re-enumerate our defaults. Some people like to fill out all the defaults to make it like very explicit. I find what happens is developers look at these install commands and there are 20 lines of code of really obscure CMake and they get afraid. And they're like, why can't I just say install? So, two minds, right? So heavily documented or the other way around. I think sometimes it's useful to leave a comment that just says, I'm relying on these defaults and link to the documentation. So, we're here. Let's talk about build types because our two destinations have generator expressions in them. Generator expressions are discussed are understood, are evaluated during the install or post-build step, right? So we've done a configuration, we have a configuration tree, we're doing the build, and now that build has resolved, we are doing an install. This configuration comes from that build. So if we had like a Ninja multi-config, which is one of our generator types, it supports multiple different types of configurations within one configuration tree, within one build tree. Yeah.
Do you mean specifically in the context of like an install block? Because I was thinking generator expressions usually ran at generate time. Like these actually don't get evaluated until install time?
Until install time. In this context, they're not going to get evaluated until install time.
And that's true because we're inside of an install like function.
Yes.
To say, okay.
Generator expressions are bound as late as they can be.
Yes,
Okay.
as late as it can be in the context in which they are evaluated.
Okay.
Fine. Let's talk about, I start my own Debian spin because I really want the latest LLVM and I hate unstable. It takes way too many days to get in there. So I'm going to start the Vito Debian spin and I'm going to, in my deb helpers, define that my CMake build type is Vito release. This sounds silly, using something other than the standard releases. Lots of distros do this because CMake has default flags and they don't like them. Arch doesn't like that we compile with O3. They want O2 and a couple other things. They're like, we're not going to compile with the release. We're going to do our own build type. Totally reasonable. Yep. So I have my CSX flags and I get my library installed to prefix lib beam exemplar. Great. I do Vito debug, right? I want to also ship developer and debug builds. Totally fine. Once again, I set my set of flags. Unfortunately, with just this command, I get the exact same archive spit out, right? And now it overlaps. Okay, so I'm smart though. I'm running my own Debian spin. Therefore, I know all about these commands. So I'm going to just set my CMake install dir over to debug, right? Perfect. Exactly what I wanted. Someone else comes in and says, you know, the last guy, he had all these custom build types, but I'm going to follow the CMake documentation. I'm going to switch them all back to debug. Fine. We switch back to debug. Debug. Right? Non-ideal. So I'm going to take a sidebar here for a second. I said I used to work on submarines. That's what enlisted crew quarters looks like. I also lived in NYC for most of my life. This is what a crowded subway car looks like for those who've not experienced it. I'm used to being in spaces with lots and lots of other people, right? With people stepping on one another's toes. There's a way that we survive these conditions. There's a motto that we use, and it's called mind your business. You are a developer in this situation. I am a packager. And it gets very confusing because every developer is themselves a packager of their own code in a way. However, there is a division of responsibilities. It is not the developer's job to tell me, the packager, where I'm going to install your libraries. And I've got a lot of libraries to work through. I want them all to work to the same. If your library works differently than the same defaults that all the other ones follow, you're now a problem child. I'm now going to maintain a patch set for your package. Because I have to maintain a patch set, I have to update it every time I update your package. Your package is now going to lag the rest of the ecosystem. Unless you are big enough that I have to do it. But don't do this to packagers. These things, as a developer, aren't any of your business. You can read from them. Do not change them. Unless you... We're devs, we all know that there are exceptions to everything. But generally speaking, don't change these. Leave the CMake globals alone. That CMake CXX flags, I set that up just the way I wanted to. Thank you very much. The environment variables, leave them alone. Read from them, obviously. Maybe there's things that are set in there, but don't write to them. They don't even propagate. They don't even leave CMake. All you're doing is screwing up the code that comes after you. Install destinations for this case, right? Leave them alone. Just leave them to their same defaults. And generally anything in CMake where the documentation says there is a reason of the default, it's already configurable by the packager, just leave it alone. Don't worry, there are plenty of places this isn't true, and you get to make all of like the free will decisions that you want. We still don't know where to put the modules. So, how to describe an install tree. We've already gotten rid of the one redundant install dir for the file sets. I am now saying, get rid of these entirely. They already default to CMake install libdir and CMake install bindir, so just get rid of them. This is fine. I wouldn't write it this way. I would write it like this. We only have one component, doesn't matter. We don't need to specify, like the fact that we have one component and its name is unspecified is fine in this situation. In general, if you do have multiple components, absolutely list them all. And as an exemplar has to kind of, yeah.
In my defense, can I elaborate on the use case?
Yeah, absolutely.
Okay. So the reason you have more than one component is because you have more than one relocatable thing coming out of a project. For example, you want to relocate your benchmarks to a benchmark environment, and you want to do that specifically. And CMake's defaults to counter, there's always exceptions to every rule.
Yes.
The CMake default for install is you wanted everything, right?
Yes.
Right. And you don't want to install your benchmarks in your production package, right? And that's another thing that gets the packager angry. Like, what the heck are all these benchmarks executables, right? So the advantage of elaborating on the component is that you do give them those ability to say, these are the things that go to the actual production environment. These are the things that go to other environments, or even other packages, depending on the package manager.
So
So I agree with you. If you don't care,
I immediately forfeit to Brett, right? I actually think the component's probably better. I wish we had a better naming convention for it.
We name it after our package.
Yeah.
So we would do like lib beam and exemplar def. And
Yes.
it's really clear what we're doing with it.
Yeah, I would be happier with something like that. But point being, we took, we're going to go back to remind your business. We took a really big, scary install command, and we can get it down to like 2 or 3 lines of code, right? So like understanding how the commands work, what their defaults are, and what is expected of you as the developer, as opposed to like not stepping on the packager's toes, can make the really big, scary things easy.
Another thing that I might say in the case of Beeman, like it is interesting because I agree with you in the general case that like really big install statements are scary and developers are like, oh my God, like thank God I'm not writing this logic myself. But at the same time, in the specific case of Beeman, and Beeman exemplar specifically, where like it stands to be an example of using correctly, like I think there is also value in just showing this is how you would do this.
And I think, so I'm of 2 minds on it. One, I think the problem is that then you get copy-paste code that, and I'm sure everyone's experienced plenty of, especially with build systems. And then these things here's my problem, right? 10 years from now, I'm going to sit down with one of these Beeman code bases, and I'm going to look at something, and I'm going to be like, that install rule was put there because it burned someone, right? That's my assumption, that you didn't write code for no reason, but you did copy-paste code for no reason. And so I'm of 2 minds on it. On the one hand, I agree, it's good to demonstrate. On the other hand, it needs to be very clear what the golden path for the simple situation is as well. So it's a tricky situation. I don't have a good answer for it yet.
For the record, I like this better. And my bar is even higher. I want to type less than this someday, but we'll get there later.
Yeah,
question.
absolutely.
Is it necessary to include this GNU install directories?
So I knew this was going to come up. That's what I said. I didn't want to talk about it. Okay, but I'm running a little bit ahead anyway, so let's talk about it. So why do you want GNU install dirs? It's fine to leave them unset. If you're just relying on them as a way for the packagers to interact with you, the command's going to check for them, and if they're unset, the command has built-in defaults. There is a module built into the CMake modules directory called GNU install dirs. Variables? I haven't used it in so long. You can look it up. If you include that, what it's going to do is inspect the environment a little bit and set up these variables for you. If you need to do something where like you need to know that this variable had like CMake install bindir either has been set or has been inherited from the command line correctly, and you need that to do some calculation in your own packaging code, that's when you include it.
Mhm.
If you're just calling install, you do not need GNU installers.
A concrete use case might be, again, advanced use case.
Mm.
You know about the CPS spec. It is not supported yet, but you want to generate it. You include GNU installers so you can embed in that JSON file things like include directories.
Yeah, exactly. That's when you would do it.
And do that in the CMake module and don't put it in every single CMake project.
Yes. But GNU installers has its own.
It is GNU installers.
Yeah. Okay. Cool. Has its own set of issues. We can talk about it some later. It's
also cross-platform. It's not GNU specific.
Yeah. It's a weird module. Okay. Where was I? This is what the problem with an unplanned talk. I don't put things close enough together. Okay. We were talking about this guy. So I'm going top to bottom in the exemplar configuration code. This is actually gated behind an optional. That's fine. I don't care one way or another about that. But what this code does is to describe a package, you have some set of options. You have package config, and there are mechanisms to do it. Exemplar doesn't, which I approve of. But you could use it package config. It's a known packaging standard. Or you can use CMake's native packaging standard, which are confusingly often called package config files. Okay, fine. Naming is hard. CMake native package config files are just CMake code that gets injected into the dependent. When the dependent calls find package, they're going to find some .cmake files. They're going to run those files within the context of the CMake execution that you are running to configure your project, and that's going to change the state. So it is just CMake code. So what these two configuration helpers is they are code generators, right? We include the CMake package config helpers module. It defines these two helpers, and they do code gen for us. So we have a template in. We have an output file. Fine, nothing wrong with this at all. We have an installation directory. This is a requirement of this function, but it doesn't do anything in Daemon's usage. You have to provide it. It's a requirement. It's not an optional, but it doesn't do anything. Fine. This is just wrong. We're just going to get rid of it. Path bars, as you can maybe hint at, is for paths. If you're doing path relocation on your project version, something's gone wrong. So yeah, we're just going to get rid of it.
The install destination sets up that file. Oh, if it's self okay, I see what you mean. Okay.
Yeah. So then we have write basic package version. Why do we have two code generators is a reasonable question to ask. We have two code generators because once you start loading a package, CMake has no way to stop. We can't like atomically unwind that you've started to open this package up. We don't have that capacity. There's a lot of pointers involved. Bad. So our solution is we have a lightweight package version file that we sit next to it. And so if all you want to do is say, hey, are you the right version of the package? Like, I see your name is correct, but are you actually what I'm looking for? We have a package version file that sits alongside it. So this is a code generator for the package version file. This is fine. The location, just dump it in the build directory. That's totally fine. Project version is the default. Again, not wrong, just explicit. I get rid of it. And compatibility exact version is fine. There's various compatibility modes you can put this thing into. What this does is by default, unless someone does a lot of work to override it, when you ask for a version, do we say, yes, I have the version you are looking for or not? In this case, it will only say exact version. You can say same minor, same major. There's a set of compatibility modes. Yeah.
If you don't have an opinion, that is the right default. That's why it's set that way. Because if you want to have compatible versions at the binary level, you have to specifically maintain that. And unless you're a Debian maintainer, you're not that careful about your APIs.
Yeah, I agree with that. Compatibility exact version is a good default. Don't use CMake to solve this problem. Use outside provisioners. We'll get there.
If you need that, it means you have more than one version of your headers and libraries installed, and
yes.
Be careful that your include directories match what you think is happening. And that's why you don't do that.
Yes, absolutely. It's just the wrong place to solve this problem, but as a final fail-safe, it's not bad.
For the record, we don't use version files in my day job. We just don't install more than one version of it, and it's not a problem.
Yeah, exactly. So Okay. So write basic package version I have no problem with. Configure package file we're going to talk about a little bit. So let's say Timmy J developer in his CMake list calls find package beamin.exemplar. What does he need to find in order for this to work? He needs to find a beamin exemplar config.cmake with this line in it. We'll talk about where this targets.cmake comes from in a little bit, but that's from the export we set up above. That's it. That's all he needs to set up for this to work. So why are we doing code gen? Timmy J developer forgets that this isn't CPython. And he asks for beamin exemplar, and then he also asks for interpreter and development components. Components. Not the same components from before, different components, not related. Components in the find package context is a hint to complex find modules. Beamin exemplar has no use for them. Anyone using the CMake native package config files has never say never, but no use for components. They exist because your system Python has a whole bunch of things that go along with it. It has an interpreter, it has a development module, it is embedded, and if you ask for just the interpreter, maybe you're asking for the host interpreter. If you're asking for just development, maybe you're asking for cross-compilation development libraries, and you've set up the environment correctly to find them. If you ask for interpreter and development, that interpreter and development should probably go together, right? Those should probably be of the same kind. They shouldn't be like, two different architectures. So these components are hints to find modules with complicated use cases. If you've passed these, if Timmy has passed components to this find package call, Timmy made a mistake. So the question becomes, what do we want to do in beamin exemplar to head this off the pass? A lot of libraries, and I've written a blog post that kind of subtly recommended this, ignore these. We don't have components. It's just extra metadata. We don't care. You ask for beamin, you ask for beamin exemplar, we're going to give you beamin exemplar. What the code generator is doing right now is allowing this situation to error out. To say, you asked for these components, I don't have them because I don't have any components, I'm going to fail. Funnily enough, if there's another keyword to find package called optional components that will still just pass. Like you can just keep asking for components all day, but if you didn't call them optional components, we're gonna fail. Fine. What we need to do is write 5 lines of boilerplate to check for this condition. I'm not going to go into what the template looks like because it's ugly and pointless. This is effectively what needs to happen. We still have our one include line. It's done. And then we need to check if there are any find components, check if they are of a required type, and then fail out if someone asked us for a component that doesn't exist. Yeah.
Could you go back to the original configure call for this? Because I was wondering at the time. I don't know how far back it was.
I don't know where I went. Oh, okay. There, here we go.
Yeah. Okay, so that I actually was wondering about that. Yeah, CMake current source dir. So yeah, so like beamin has to check that in. Like I guess I'm just wondering for the .in file there, you were talking about why do we need code generation here? CMake still goes and just injects additional stuff in there.
This is a template.
Yeah, that makes sense.
It has some variable things in it where it is injecting code.
Right.
And one of the things it injects is it injects a bunch of macros, and then at the bottom, the template calls the macro that does this check. All I've done but it's ugly and I don't care about it, and I never want you to use this anyway. So just if you care about failing on components, either write the boilerplate or hide the boilerplate somewhere, but just write the 5 lines, and then you never need to it's less lines than this configure package call is.
Yeah. Okay.
Yeah. So if you want to fail, put the boilerplate somewhere. This can be even shortened.
You're just saying you could do this. That's the purpose of okay.
But then what happens is that entire configure call goes away. This is just the file.
I see. Okay.
And then you just call install on the file. You don't need to configure it, put it in the binary dir, install it. And this is our final install. So this installs our config file either because we generated it with our configure, or you fixed it and you just don't need to go through the code gen anyway. You should still generate the version. It's just easier. And Destination is fine. Doesn't matter where this goes. There's no standard. Okay, there is a standard, but it has 30 options in it.
Right.
Pick one.
That's why I put it in there, because if you don't care, that's fine.
Yeah, it's fine.
Can you go back for a second? One more back. Just a curious question. So there is a find package beamen.exemplar,
Mhm.
and the find package has two ways to find something. Either it's
Yes.
a module or config. Since beamen exemplar produced the config, maybe it makes more sense to always say find package beamen.exemplar config.
You are correct. I was dodging that issue, but you've raised it, so now I must address it. So find package has two modes. CMake is very old. CMake native config files are newer compared to the age of CMake. In the olden days, we only had find modules. We only had the version of what we were doing for Python. And by we, I mean Dan. We only had find modules. So we had this mechanism of searching for find modules, and that was the mechanism that find package used. Then we invented the native package config files. What then happens is we need a new mechanism for searching. If you leave off config from find package, it will do the module search first, fail because beamen exemplar doesn't have a module search, and then go to config. If Timmy knew what they were doing, they would put config there. But Timmy thought beamen exemplar was a Python interpreter, so Timmy probably doesn't know what they're doing to begin with. But that's on the consumer to be correct, right? There's nothing beamen can do to make the consumer smarter.
Well, and Timmy doesn't have to for this project.
Yes,
Like,
this
if
will work
you
either way.
don't know anything about the
But-
project, config's a good default because, like Google Test or something, you want the one that ships with the package, not the one that ships with
But then-
CMake. But like, you might be marginally faster, but you probably won't notice. Like,
No, but then maybe a general recommendation could be that if you do use find package, always have the config because the module search is old and most likely something wrong.
I would say it has too many pitfalls to be a recommendation. There are plenty of modules that need to be find modules.
Yes.
And there are extremely few modules, like Vulkan is the only one I can think of that still ships, that has like a find module and a config, and you could run into the wrong behavior by doing the wrong thing. So like, it's so rare to run into the degenerate behavior, and doing the wrong thing can cause bugs in enough cases that I would say I'm hesitant to ever give a recommendation on what's right here.
But again, then the other question in case of beamen, right? So if one beamen depends on another beamen, right?
Oh.
So in that case, would it be the better?
Yeah, absolutely. In your documentation for, I want to expand it just a little bit beyond beamen. If your project only ever ships a config file, in your documentation for how do I use this project, absolutely include the config in the find package.
I'm still not sure how that relates to the future work with the CPS stuff. That whole flag.
I
probably
agree.
That whole flag probably means nothing in 3 to 5 years. So
Yeah.
I don't get too dogmatic about it.
I agree with that too. Yeah, find package is complicated, case by case basis. Figure out what the right thing is.
I think it's reasonable to expect CMake to give you a warning if you got it very wrong, or you could expect the person shipping the package library to give you a warning if they get it very wrong.
CMake is very trusting. We assume that Timmy knows what he's doing.
like if by policy you're going to ban
Yeah.
find module someday, maybe that's reasonable. Like there will be a CMake warning saying
Yeah.
you're using a find module, stop it, and you should you should pay attention to your warnings to make sure that you clean that up.
Okay. How am I doing on time?
We have like 35 minutes.
Oh, perfect. This thing, components, yada, yada, yada. Wait, where was I? Okay, so we had that single include file that we needed to do, right? So there's really 3 install commands. The install command for the files, the install command for the targets, and then the install command that's going to put this CMake native package config file where we expect it to be, right? So 1, install command for the files that we generated, or we just wrote by hand. 1 for the targets themselves to say, I want the targets, the libraries and the binaries to get in, and then 1 for the CMake native package config file. This is the CMake native package config file install. Export beamen exemplars, fine. Once again, I would arraign it beamen exemplar targets to make it clear that we're talking about the target group, not the package itself, not like the package or the beam exemplar target. Destination is fine. Note that the file name is already beam and exemplar targets. That's where that include statement comes from. When we said we needed this one include line, it needs to be this beam and exemplar targets. This is where it comes from. Destination, totally fine. Namespace, fine. This thing's fine. I'm totally fine with this. Works. But note that we said we could narrow that config file down to a single include statement that just included the targets file. What if we just named the targets file config? Right? So what we have in beam and exemplar config is a single include line, ignoring the components problem for a second. If all we're going to do is include this other file, screw this, like, just generate the file correctly. Just give it that name. For beam and exemplar, this would work. Ignoring the components problem, this would work. So why do we go through the indirection? Dependencies. Beam and exemplar has no dependencies, and so this is not a problem for beam and exemplar. But other packages have dependencies, and this whole rigmarole, this 3 installs, the file generation, is all because we need some place where the developer can tell us about the dependencies they want to find. So in your build, you called find package and you gave it a bunch of options, requireds and versions and whatnot. You don't need to replicate those. You do need to replicate the list of names. We have a macro called find dependency that remembers things like, is this required? Is this not required? Is it quiet? Is it not quiet? Things like that. This is dumb. We can do better. Right? This is something we can keep track of. CMake has a lot of places where it doesn't have enough context, but it can do this.
It's already known, right?
What?
It's already known, right?
Yes, it already knows it. We called find package, right? We know it. And we called target link libraries. We know everything that went down. There's no secrets here. So, how do we describe an install tree in postmodern CMake? We still have almost everything the same. We've renamed the file to beam and exemplar config.cmake, and we've told it export package dependencies. Handle my package dependencies for me. Now, this comes with the standard caveat that this is still an experimental. So you have to go to the CMake source tree, you have to go to help dev experimental and go read how this feature works and how to turn it on. But eventually, once I fix the last 7 bugs in this, it's gonna ship. And then you will not need to do the indirection through the config anymore. You're still allowed to. If you have complex requirements you want to put there, still allowed to do it. You just won't need to handle dependencies there anymore. Okay, moving on to other experimental stuff. All of this still sucks. Even if I can get this down to like 2 or 3 install calls and only 1 file generator, it all still sucks. It's bad. We didn't solve this problem yet. This is the new era. This is the frontier. We've done a lot of good on the source trees and the build trees, and there's still some wish list items, but getting things into the install tree is still a problem, and then discovering things that we put into the install tree. I was a CPS, hater's a strong word, I was a doubter. I didn't believe it would succeed. Working on specifically these workflows of how do we make the install find package as simple as possible, I've come to believe in CPS because I think it is the only way that we can get all of that information encoded into a single file in a single command that's going to work not just with CMake, with everyone, right? When we did C++ 20 modules, we didn't just do that for CMake. Ben Bakel was out there in the Meson issue tracker and in the XMake issue tracker saying, and the other build system saying, this is what you got to do. This is the formats that we're implementing, and it's moving. I hope the common package specification is going to do that for package discovery. It's real simple. Those installs that we had for generating the example, the export targets and the files, all of that just becomes a single install command, package info, the package name, the targets that you want to do. You still have to install the targets and describe where the libraries end up and stuff like that. But all of the metadata becomes a single install command, and it still works just with plain old find package. Now, it doesn't actually, because like header sets don't work, but in concept, this is going to work and be, one shot and done, and cut the amount of overhead, semantic overhead for working with
we'll
installs.
Get header sets in a CPS. It's just not. It's not hard.
Yeah.
Kind of semi question, but in all this, when you took the daemon exemplar and showing all these commands, there's like so many tons of repeats. Right?
Yes.
Why not just have it like, I'm not saying add a new argument to add library, but why not just say any add library by default install?
We'll get there.
Okay.
It's coming. So this is CPS. It cuts down on the semantic complexity of this problem by a lot. And this is where I wasn't sure if I was going to be at like end time or not. Let's change gears real quick. C++ is not the only programming language in the world. Python is a C++ ecosystem. Steve always tells me that the most common C++ build system that he interacts with is Python. My students at university don't know what a compiler is. Can't run one, never seen one, don't like one. They built C++ all day, every day, because they invoked the Python build ecosystem. And it just built C++ and linked it together and found packages and like did all of it. I am obsessed with a couple of the peps that describe how this works. And I'm going to try and make you as obsessed as I am. And then hopefully you are going to like pin down someone on WG21 and tell them to bring back the ecosystem papers. It used to suck so bad. Packaging Python, especially C extensions, sucked so bad. You think CMake is bad? Do it in Python, but without like the Meson or the Bazel or any like the build tools, just plain Python. That's what distutils was. Like no transitive dependencies, flag soup for days, but you have to shell out from Python to package config. It was nuts. This was miserable. There's an ancient issue on, 5 years ago, of like, I don't want to engage with this at all. I've already pre-compiled my packages. I want to just stuff them into the Python packaging format. This is asked and answered by me. It was a fun time. We fixed all of it. They solved this. First, they solved packaging with PEP427, which describes the wheel format. So prior to this, CMake packages were just source tarballs, right? You collected the sources, you collected the build system as part of the sources, you shipped it out as a source distribution tarball, and that was it. Python said, we're going to standardize what the built layout, what an archive looks like, right? This is Debian, this is RPM. They just said, but we're going to standardize that language. Why? It's called wheel. It's trivial. It's not interesting at all, but they standardized it. Then came the big boys, PEP517 and PEP518. PEP517 has some glorious definitions in it, and we're going to go through them together. A source tree is something like a VCS checkout. That's it. They're just like something, right? Git, SVN, whatever. It's some sort of thing that you pulled from source control. The actual building of each source tree is by a build backend. The source tree is going to dictate how you build it, right? I don't need to care about what my front end user, it doesn't matter if you're using pip or UV or poetry or flit or whatever your front end is doesn't matter, because how the code is going to be built is by the source tree's backend. There will be an integration front end that users might run that takes a set of package requirements and attempts to update the working environment to satisfy those requirements. When we're talking about provisioners, this is what we're talking about. So we have these things, right? This is CMake, this is Meson, this is XMake, Bazel, all of them, right? We have package managers. This is Conan, this is Stack, this is VC package. The missing part is the build front end. We don't have this. A tool that users might run that takes arbitrary source trees and builds them. That front end is what's going to invoke the provisioning, the integration front end, find the build backend. The build backend might be a dependency of the build and invoke it. That way, from the user's point of view, whatever their front end is, whatever makes them happy, works with any set of source trees using any set of backends. This is what PyProject.toml looks like. This is one of mine. It's got some random standard metadata in it, right? Boring. It's got dependencies in it, not complex ones, but you can make them arbitrarily complex. You can split them out into groups and things like this. So test and benchmarking, and there's a whole spec on how the versioning strings work. I'm sure it's very interesting for people who care about stuff like that. I typically don't have complex dependencies. PEP 751 is a file format to record dependencies for installation reproducibility. So they have an entire format for how to describe how to do the installation step. Oh, sorry, sorry, this is the problem with writing these slides like an hour beforehand. This is all PEP 517. This is all PyProject.toml. One thing you might want here is a lock file. PEP 751 is a lock file. They standardize lock files. It's awesome. PEP 518 is the PEP for specifying minimum build system requirements for Python projects. It lets us put in, hey, I build with CMake. In this case, literally, I build with CMake. Go get CMake. You need it to build me. And it pulls it down. The front end pulls it down. And then it builds the CMake project. And the student, the user who doesn't care about C++, none the wiser. Has no idea, pulls down Ninja. It's awesome. It works so well. There are a bunch of Python build backends. Hatch and Flit are really popular. They do things like define the project based on its file structure. They do things like have fully declarative extensions to that file structure. If you want to get these things into C++, CMake might get there eventually, but wouldn't it be nice if you could just write your own build system, and instead of having to get massive adoption for it to get it on everyone's machines, you just did it for yourself, it worked for your project layout, and in your build description, you just said, hey, when you're building me, pull down this build system. It knows how to build me, right? There are dozens of build systems for Python. No one knows about any of them, and you don't have to. You decide for your code what the build system is that works for you, and then when other people need to integrate your code, they don't have to care about it. C++ and Python are not the only programming languages. Everyone knows this is coming, right? Everyone ready? Brace yourselves. I don't know Rust. I'm not going to talk about it. I don't program in Rust that much. I'm not that good at it. But I do need to talk about cargo, right? Because on the one hand, it would be very, very nice if we had the ability to describe build backends and we had this front-end tooling and we could swap all these things out. But that's a lot of work. That's a lot of infrastructure. It's not coming tomorrow. We probably do want, in our existing build tooling, the stuff that's popular right now, the ability to reason about source trees, the ability to reason about, if not the entire build, the parts of it that can be described declaratively. And Cargo presents that, right? It's mostly declarative. It's got same defaults for the 99%. It's broadly keyed off the file system layout, but you can escape hatch out of that if you absolutely need to. And then it does just have an escape hatch build.rs, right? You can just escape hatch, go out into Turing completeness and do whatever the heck you want. I think this is the approach that's going to work for C and C++, right? We want to have the capacity to describe, hey, these are my libraries, these are my executables, these are the associated sources. Maybe if you subscribe to a specific file layout, we can even detect some of that. And then at the end, if you say, hey, I'm actually not done. I need to talk about my weird zlib fork. You can say, and use that as the starting point, then jump into my CMake list and let's go full Turing complete. And you can do math and reason about JSON and do all the crazy stuff, right? So this is the future. If I have to talk about CMake 4.0, what I want to see, it's better find package, better install, and then leading the rest of the ecosystem into these patterns that we've seen work for other language communities, which were bad. They were as bad, if not worse, than C++. It's not hopeless.
They're still like the dependency binning thing you talked about is underspecified for a lot of Python workflows, and it definitely wouldn't work for us. But it is in the right direction, and it's better than what we have.
So this is still CMake talk. I want to just very quickly say, can we fake this provisioning system? Can we figure out something that kind of works like it? And the answer is yes. Yeah, absolutely we can. But this is a CMake talk. You have to write in CMake lang. People have done this. VC package has done this. Conan's done this. I've only know of one more instance of this being done. So Brett Brown has done this.
Twice.
So let's talk about them just really quick because they're interesting and they're useful if you haven't engaged with this yet. The way that VC package and Conan do it is they hijack the toolchain file. So you invoke CMake using this toolchain script. If you go to the toolchain documentation, it will be zero help here. Toolchains were intended, that like the use case that they were imagined for, cross-compiling scenarios, right? Toolchain may be specified with the information about compiler and utility paths. But they run when you call project. So you can put anything in there. And that's what people do. And so this is fine. I'm actually not as upset about this as you might think. I don't think this is a bad hijacking. There's good reasons for this. I don't have time to get into all of them, but I don't hate this. But a couple weeks ago, I was rewriting the project command, and there was this weird variable in there called like project top level include. And I was like, I've never seen this before in my life. Fast forward to like today, reading the Beeman source code. Brett uses CMake project top level includes as his way to hijack and provide dependency precision. So this is how you invoke CMake. You tell that, hey, I want to use this file. It kind of works the same way that the Conan and the VC package toolchains do. It's simpler. It uses a very little known CMake command called CMake language and a very little known CMake feature called set dependency provider to set up this sort of provisioning front end. It uses lock files. They're very nice. It's got a whole bunch of edge cases it won't survive for, but it's really, really cool. I like this a lot. I need to say, when I talk about fetch content, for years I've been saying you need to put it in a dependency provider. And when I was saying that, I was kind of saying it as like a dare so they would leave me alone. Like I said it in a way like, oh yeah, when you put it in a dependency provider, then we'll see how it uses. And then Brett went and did it and it works nice. Like it builds fine. It works nicely. It works. It has issues around all the things that complex package management has. So it has issues around, there's a package out there, it starts with G, it rhymes with RPC, that vendors all of its dependencies, right? You don't want that in package management. You don't want that protobuf and their vendored version of protobuf. And so you have to patch all that stuff out. This doesn't have a solution for that. But Beeman projects are supposed to be exemplary. They don't have this problem. So if you know your projects, your upstream dependencies don't have sort of degenerate behaviors, this works. And I really look forward to like expanding on this as a solution, at least for lightweight. Yeah.
To give credit where it's due, all the interesting top level includes and all that was all Craig Scott's work.
Yes.
It is literally in the CMake docs.
Is it really?
That's what I want to say.
The only thing that I added was the JSON file thing, and that uses the baked-in CMake support for JSON parsing that you wish wasn't in there, but it was in there, so I used it. It works on Windows. Importantly, I don't have to be like, well, I show up the Python, but do they have the Python? CMake is the most portable build system scripting language out there.
Yes,
so
unfortunately.
many people should grow.
So yeah, this injection can happen. I haven't read all the CMake docs apparently. Get right on that.
It's in the professional CMake book too, I'm sure.
It's an official website as well. When you search for set dependency provider, it will be there as an example.
Right.
Excellent. I've never set a dependency provider. You caught me.
Well, this is the way it's for.
So, wow, I even left a blank bullet. I was finishing this as we walked into the room. I nailed it on time. I'm an expert. Okay. There is just I talked about moonshots at the beginning of this talk. There's a whole bunch of things in the CMake 4.0 era that I would also like to see. I just want to talk about them briefly. CMake 4, like everyone always says, like, how do I space this stuff? A CMake formatter is long overdue. I'd like to get it done one day eventually. The problem is you have to write a new parser. The Yak parser is limited.
Almost accurate.
Linter goes in the same box. I think the best we're going to do for a linter is more strict runtime checks. What I mean by that is you have a conditional somewhere in your CMake language. I'm not going to be able to lint the else branch because I'm not going to take it. But I'm not going to re-implement a CMake, like a Clang tidy for CMake that evaluates both branches and figures it out. But we can do at least as well as, hey, if you're calling these commands in this way, having a stricter set of warnings. If you're using the CMake 2.0 era directory level commands, hey, maybe don't use those. Like, here are the alternatives. So I think stricter runtime checks is a step towards a linter, but I'd like to see a full-scale linter. My white whale, scanner-enabled code generation. You have a protobuf file. Protobuf describes its outputs in terms of the content of its inputs. So the set of files that will be generated depend on the file input. CMake dies on this. It has no way of doing it. This comes up all the time in interface description languages. I want to get it fixed one day. All the projects that I like bootstrap their package managers if no one else has. I want to see better integration for that. And whatever nightly build just failed my last MR, I want to deprecate. All right, guys, that's what I got. Questions, comments, concerns? Gripes and grievances? What up?
A question. So you said the CMake 4 would be about packaging and how to install.
That's what I imagine it will be.
Yeah. What's about presets?
Okay, presets. That's an excellent question. Presets need someone to love them. They don't have a champion right now. They don't have customers who are dying for new preset features. Everyone likes them, no one loves them, and no one needs them badly enough to say, I'm willing to put in the work. And sometimes the work is just like, what does the correct answer for presets look like? Right? What problem spaces is it trying to solve, and what's the right way to solve those problem spaces? Because right now, it's not the end of the world to describe a matrix in your CI and use that as the mechanism that you use to configure CMake, right? It's totally reasonable to do that. Is presets the right place to solve that? Maybe. I don't know. I don't know what the right answer looks like. It needs work. I would like CMake presets to be useful. Right? I think they solve a lot of problems for me if they didn't have the problems they have with multiple inheritance and matrices and all those things. Yeah.
I'm going to have opinions about this, and we should talk about it more later. But I think the thing we're trying to do with presets belongs more at the higher level tool that really knows what you're trying to do and doesn't have the XY problems. And then maybe we have declarative ways inside the repo to say things like, yeah, I love sanitizers, and yeah, go ahead and coverage is supported by me. But you don't, presets are, despite the JSON format, are kind of a procedural description of what you're going to do instead of being more of a declarative description of what you want. Right, and I think the sweet spot is more like that. And again, think about PyProject Tarmo, think about Cargo Tarmo, even the way that like Bazel commands are phrased. It's very much like I'm describing the project, some properties about the project, and then I'm doing complex transformations that turn into I get this dependency, I set this flag, I do that install. Right, so like I think presets are a good local maximum for I don't want to do a lot of typing. It's 5 things I do day to day. I just want the one-liner for it. It's great for that, but I think it's a local maximum in that respect that we're never going to get to the point where anyone could just hit something build with TSAN and it just does it. I don't think presets is going to get us there.
I can tell you my personal presets nightmare, which is that I don't care about the project level presets, right? If I'm in CI, that CI script determines how CMake is going to get configured. But I clone a lot of projects to my laptop, right? And I have 3 compilers on that laptop, right? And I have specific ways they want to be invoked. And I want them to be invoked the same way for every project. I don't want to have CMake user presets.json and have to copy that into every single project. I want that into like a CMake configuration directory that my IDE knows how to find. And these are like my base presets, right? Like when Vito wants to build a GCC debug build, this is how he does that for any given project. Like this is the...
Or even say you can like say, oh, I want to build for that platform on that OS, like more triplet, right?
So that's the problem. So like you need at the level of what are you trying to do, even a little bit before your dependency provider.
It's like a step before.
So the thing that gets closest is Conan 2.0 will generate presets into your Conan install directory, And that can be hints to things like your IDE to yourself about like, oh, I set up the profile that include thread sanitizer because I'm going to do fuzzing.
Yeah.
The coding will know about your fuzzing stuff, but it will give you like the middle to the end of that workflow. Does that make sense? So that's the closest.
Yeah.
Again, it's a generated file. And
Yeah,
it's not an authored file. It's an intermediary like interop file between your package manager and some other things.
The solution I use today is Vector Aboul's extension for VS Code has this. He called them CMake toolkits.
Yeah.
They're just, this is the set of things that you use the most often on every single project,
Right.
and they follow the IDE around. I would love to get that upstream, but yeah, it needs someone to love them. It needs a champion. Excellent. I answered all the questions. Everyone knows everything about CMake. And you're all going to walk out of here and just start fixing packages left and right. I'm never going to see another line of bad CMake code.
I'm just going to package all the code, right?
Yeah. That's a good start. Maybe that should have been the talk. Write install. Like, you can't go...
So if we have a little time,
yeah.
The only thing I love everything you said. I've raised the bar in a few places if we're just dreaming and wishing and stuff. I think even the fact that some platforms want or maybe require package config, despite Vito hating that format, and other platforms, you really want the CMake modules installed. Pretty soon we're going to have the CPS in the mix. Like, I feel like that's even a thing that needs injected into your CMake configuration itself. And so I feel like even the thing like the package in export command should really be abstracted away. Like, we should really find that scene for your dependency provider can encode the expectations for what the installs look like for the thing you're shipping to.
Mm-hmm.
And there's more of an abstraction layer where you say, whatever that, like, it's like dependency providers, but for installs, it's like my layout provider thing. And it knows, I can walk your target properties, and I know, oh yeah, well, I'll generate you that package config file. I'll go ahead and make sure you have those CMake config packages. I'll make sure the CPS files are there. I'll take care of all that for you. All you really need to do is have good target properties, and I'll warn you if you didn't, that kind of stuff. And that's totally doable because I got implemented that. So, like, we just need to find the standard for that and get people excited about that. And I think that's totally doable in the 4.0 range, especially if we have enough volunteers and adopters and stuff.
This goes a step farther. Something that I've, talked to Brad King over pizza is that, like, find package itself is kind of redundant for many use cases.
Yeah. Well,
You call target link libraries, right? And you give it a list of requirements. You say, I need zlib. And you could include inversion information in there and stuff like that, right? All right, you've described it. Obviously, it must be found at that point. You don't need to say, I need to find it and I need to use it. That's redundant.
It'll tell you if you didn't do it.
Yeah.
CMake knows you didn't do it because it'll tell you didn't import this. Like, CMake goes, like, you have target link libraries with the colons, like the namespaces. If you missed and find package for one of those, CMake will tell you should have found.
You should have called find package. So therefore, we must know that we needed to call.
so why didn't you just call find package?
Why did we? Yeah, exactly. So I've thought about the same thing of that. The actual the minimal set of information that you actually need to communicate to a build system is definitely way smaller than where CMake is today.
Right. Then again, I implemented that too, but yeah.
All right, guys.
It wasn't just me, but a lot of good, smart internal Bloomberg people implemented something like that. So, like, yeah. At Bloomberg, we don't write find package unless we want to bring in a code generator or something like that.
Stop writing code generators. No.
Well, yeah. We have things like protobuf. It's not optional.
We have reflection now. No one ever needs to write a code generator again.
Yeah.
Thank you for your time.
Sure.